This might be kind of short because my last lecture is like 15 minutes over section 10.3, where I actually took a minute to text. Sorry about that. It was actually one of you guys that makes you feel any better. Anyway, I got some more identities from section 10.3. This book is so consolidated, they actually put some identities in it, and it surprised me when I turned the page. So I just cut the last lecture off. So what I'm going to do is lecture traditionally, and then I'll throw in the other identities in lecture 3, plus do some examples, because basically the textbook, throws them in without proof. So anyway, so here we go. Recall. Now, cosine of 2 theta is 2 cosine squared theta minus 1, and it's also 1 minus 2 sine squared theta. What I'm going to do is solve for cosine squared, and I get basically 1 plus cosine 2 theta over 2. And I'm going to solve for sine squared, and I get, let me see, put that over 1 minus cosine 2 theta over 2. Well, there we go again, change the colors on me. Now, just for kicks, I'm going to let theta equal alpha over 2. Give this formula a new look on both. So we get cosine squared of alpha over 2 equals 1 plus cosine, well, 2 times alpha over 2 is just alpha. That's what I was shooting for. And I get sine squared alpha over 2, 1 minus cosine alpha all over 2. And then we get cosine alpha over 2 equals plus or minus the square root of 1 plus cosine alpha over 2. Now, the plus or minus will determine, what quadrant does alpha over 2 lie in. Cosine goes plus, minus, minus, plus. So if alpha over 2 is in the fourth, it's plus. If alpha over 2 is in the third, well, it's negative, etc. And we also get sine alpha over 2 plus or minus the square root 1 minus cosine alpha over 2. These are called your half angle formulas. Now, tangent is actually pretty cool, because tangent alpha over 2 is sine of alpha over 2 over cosine of alpha over 2. Now you can bust up square roots so the 2's go away and you're left with plus or minus and then you can smash them together. Now plus, plus with plus, minus with minus, it's safe is to just keep one plus or minus, because you know where you're at. Alpha over 2, we know the location, we just put the correct symbol, but you can smash them back together. So, cute little proof. Now, without proof, it actually has another one, sine alpha over 1 plus cosine alpha. I personally never use this one, but it's in the book. And there's a third one, cosine alpha, 1 minus cosine alpha over sine alpha. So, kind of cute, kind of clever, the last two, but I can safely say I have never used them to help me out of anything. Now, you got the corresponding problems that go with it, like the cosine of pi over 12. I don't like these type of problems, but, you know, pi over 6 is 30, so pi over 12, they're really asking me cosine of 15. Now, I could work it like this, degrees, 45 minus 30, from a previous section, but how about going like this, equals cosine of 30 divided by 2. See, that's the half angle formula, which is plus or minus the square root of 1 plus cosine of alpha over 2. But 15 degrees is in the first quadrant, and it's got to be positive. And unfortunately for everybody here, cosine of 30 is the square root of 2 over 2. So this is no fun, because this is over 1, crisscross applesauce, 2 plus the square root of 3 over 2 over 2 over 1, which is the square root 2 plus the square root of 3 over 2 times 1/2, which is 2 plus the square root of 3 over 4, which is 2 plus the square root of 3 over 2. Disgusting. But we can also ask maybe a better problem than that. So I like when they say cosine x equals 2/5 x in 4. So x is between 270 and 360. Now let's figure out where x over 2 is, because they're going to ask us that. X over 2 is in the second. So if somebody asked me to do cosine of x over 2, and I know x over 2 is in the second, it's 1 plus cosine of x. Well, it was given to me. And that's 7/5 over 2 times 1/2. That's 7/10. This is the square root of 7/10, which is the square root of 7, square root of 10, square root of 10, square root of 10, which is the square root of 70 over 10. Disgusting. I don't like that. Sine of x over 2. Well, that'd be easy. Well, anyway, there's multiple ways you can work these. Like tangent of x over 2. Is, well, you know, tangent goes plus plus, so it's going to be negative because we're x over 2 is in a second, and you could go with the 1 plus 2/5, 1 minus 2/5 formula, which is the square root of 7/5 over 3/5, so 5/3, which is the square root of 7 over the square root of 3, square root of 3, square root of 3, square root of 21 over 3. Painful, painful. So those are the half angle formulas. and I don't use them a lot. I use the double angle formulas a tremendous amount. But there's a little bit of extra lecture I got to add on to this to help you in calculus. So this lecture is only 10 minutes, so you got to suffer here. Recall that cosine of 2x equals 2 cosine squared x minus 1. You will memorize that this way in trig. That's your formula. That's what you use. But in calculus class, you memorize it this way. Cosine squared x is cosine 2x plus 1 divided by 2 divided by 2. So if I say cosine squared x, sure, it's 1 minus sine squared, but that's not the one I want. Cosine squared is cosine of 2x divided by 2 plus 1/2. And sine squared of x, I'm going to work beneath it. Cosine 2x is 1 minus 2 sine squared x. Push it over, push it back. Okay, there we go. It's 1/2 minus cosine of 2x divided by 2. So it'd be better off to memorize the top one as 1/2 plus cosine 2x over 2. And the bottom one is 1/2 minus cosine 2x over 2. Because when you're in calculus 2, they're going to ask you this question. They're going to ask you to do the antiderivative of sine squared x dx. And you need to know that that's, here we go, 1/2 minus cosine 2x over 2 dx. This is very easy. This is 1/2 x minus sine 2x over 4 plus some arbitrary constant c. When you get into calculus, this part's easy. But if you don't know this formula and where it came from, well, then you're just kind of hosed. And they always, like, your trig teacher should have taught you. Well, yeah, I taught you this one. I didn't teach you to isolate the sine squared. Yeah, I did. I'm doing it right now. Isolate the sine squared. So sine squared, 1/2 minus cosine 2x over 2. Cosine squared x, 1/2 plus cosine 2x over 2. And then when you get to calculus, and on this day where they're saying take the antiderivative of sine squared dx, they go sine squared, and you go 1/2 minus cosine 2x over 2. And then if you write that down, I promise you can get into that and just as fast as I did. Granted, you don't know how to do that yet, but it's really trivial. Like world's easiest calculus stuff. Literally, it won't even hurt your brain. But if you don't memorize it, then when somebody does this, oh yeah, that's 1/2 plus cosine 2x over 2 dx. Well, the integral of that is obvious, 1/2 x minus sine 2x over 4 plus some arbitrary constant c. So if you memorize the formula for cosine squared, which really came from the double angle formula, one of the 3 double angle formulas of cosine 2x. So we're going to work on memorizing it, so when you get to calculus, you don't have to worry about memorizing it. That's it. Still not done. There's another bunch of identities that they squeezed in this section, and I'm trying to work my way through them. There are ones where the identities coming up, I don't bother memorizing them, but I have used them quite a bit in my mathematics life. It's just that even I look them up. So we're going to write them down. They're quite useful, but you'll want to talk about the world's quickest lecture after I write down the 8 formulas. Like here's an example. We should be out of that lecture in about 10 minutes. And then finally, we'll have cleared section 10.3. And then it's safe to proceed. See you later. Good luck, guys.